Okay, so equation for circles. All right, this is what our equation looks like. Okay, and this is called the standard form for the equation of our circle. X minus h squared plus y minus k squared equals r squared. X minus h squared plus y minus k squared equals r squared, where the center of our circle is at the point h comma k, and the radius, meaning the distance between the center and the outside of the circle, equals r. Okay. So if we know the center and we know the radius, we can plug those things in to get the equation of our circle. X minus h squared plus y minus k squared equals r squared. Now we're going to go both ways. We're going to be given the equation, and we should be able to sketch a circle from that equation. And we're also going to be given a circle, and we need to identify what the equation is from the circle. And then after we go through the notes, I'm going to show you how using Desmos calculator is awesome, because it can help verify a lot of your answers. Even if the test has you sketch a circle on it, it's very easy to verify if you did it correctly by looking at the Desmos calculator. And I'll also explain how normal graphing calculators just don't work as well as Desmos does with regards to circles. All right. So there's our equation. Let's see if we can identify the center and the radius for these three examples. Okay. Now, you do need to be careful. Again, the standard form is, okay, so we got our x minus h squared plus y minus k squared equals the radius squared. All right, so we need to be careful now. Even though we're subtracting, that's a positive h value. Okay. Subtracting k, it's even though we're subtracting k, it's still a positive k dot, k dot, k dot. So here, I know my h, my center is going to be at 4, -7. Right? And the reason is because this is like subtracting a -7. Right? So if you have a plus in there with your circle equation, that means that you have a negative x or y value. In this case, because it's with the y, we know that's a negative y value for our center. To find your radius, because this is supposed to be the radius squared, what we're going to do is you could set up an equation, or you could just take the square root of this number on the right-hand side. Square root of 100 is 10. Okay. So we have a center at 4, -7 with a radius of 10. Second one, our center, I think the center is the easy part. It's going to be at -14, -3. Our radius is a little bit harder. Now we're taking the square root of 60. That's not a perfect square. So I need to figure out what's the biggest perfect square that goes into 60. Unfortunately, I think it's the smallest perfect square, or one of them. It's 4. And square root of 4 is 2. So my radius is 2 radical 15. Right. Now, that's hard to sketch. Okay, because that's not going to be a whole number answer. If you've got a nice grid, right? It's gonna be hard to pinpoint exactly on the grid where your points go. You could sketch it and it would be pretty close. It's not gonna be perfect. Okay? Technology will help you out a lot. If you need to graph this, the Desmos calculation can do a much better job than we could do for you. Right? But we can identify that radius line, which is valued. And our last example, our center is going to be at 5, 6. And the radius, let's see, we got to take the square root of 84. Let's see, 16 going to 84. Let's say 4 is our biggest one again. 4 goes into it 21 times. Two radical 21. All right, what would our radius be? What would our radius be if we had an equation that looked like this? It had like x squared plus y squared equals 16. What would our circle look like if we had that? X squared plus y squared equals 16. Where would my center be? Yeah, it'd be at the origin. The only way this could happen is if I was doing like x minus 0 squared plus y minus 0 squared. Okay? Which happens, okay? We do, in fact, probably happens more often than any other center. But yeah, this is basically a circle that's centered at the origin at 0, 0. Okay? The radius part is still going to be the same. It's going to have a radius of 4. Right? Because the square root of 16 equals 4. Right? But if you ever have just x squared by itself or y squared by itself, that's telling you that that coordinate, either your x, in this case, both x and y, that x and y are both going to be 0. The center will both be at 0. But you might have one that's just like just x squared. You know the x value of your center is 0. If you have just y squared, the y value of your center is 0. Right. Next couple involve writing an equation and then sketching a graph. This one goes through writing an equation for us. Write an equation and graph of a circle with center at 3, -2, and a radius of 3. Okay. So what we're going to do is we're going to type in our h, k, and r. Okay. Well, h is a positive 3, so x minus 3 plus y minus -2 squared equals 3 squared. Well, subtracting the negative is like adding. So we get x minus 3 squared plus y plus 2 squared equals 9, because 3 squared is 9. All right. Now, yes, we have the equation. It's probably easier to identify the center and the radius from up here, but if we were just given this, we should be able to do the same thing. Identify your radius and your center. All right, let's go ahead and plot our center first. 3, -2. Let's jump to red here. So 1, 2, 3, -2. Now, when I sketch a circle freehand, I like to get my 4 points. Straight up, straight down, straight right, straight left. That way it gives me, I don't draw circles. So, but at least I'll have 4 points that are right. Radius of 3. 1, 2, 3. All right. And from there, do the best you can. Just sketch it. Okay. Mine always end up looking like eggs. That one looks the best. All right. Take a look at another one. For an equation, you can graph a circle with center at -4,1 and a radius of 5. All right, let's plug these values in. So x minus the -4 squared plus y minus 1 squared equals 5 squared. Well, subtracting a -4 is like adding 4, so x plus 4 squared, y minus 1 squared equals 25. There we go. There's our standard form for this circle. Or -4,1. Radius of 5. That was not nice enough. Took this off the graph. 1, 2, 3, 4, 5. Bigger the radius, the more room for error. All right, give my best shot. It's not good. I think it looks like a balloon. All right. The other things, sorry, I was kind of rushed when I was typing this up. There are a couple other equations you guys should keep in mind. Because there's a couple questions that ask this. So area is pi times the radius squared. Okay. Guess I could write it right now. Area equals pi squared. Circumference is either equal to the diameter times pi, right? Or 2 times the radius pi. Right, same thing, just the diameter is 2 times the radius. Just keep that in mind. There are a couple questions that ask you to kind of work backwards. They say, given the radius or given the circumference equals this, right? What is the radius? Okay, or given the area equals this, right? Tell me what the radius is, or tell me what the circumference is. Which means you have to solve for the radius and then plug that in to get your circumference, right? So there are a couple questions that do use these, and these are good practice for end of course test questions because they like to do that. They like to give you one fact, and from that fact, you have to kind of go backwards to get a building block, in this case, like a radius, and then you use your radius to find the other part. Okay. The one last thing I did want to show you is how you use the Desmos calculator. And it's as straightforward as can be. The nice thing with Desmos, compared to other graphing calculators, if I were to try and put a circle, the equation of a circle in this calculator, it would only graph the top half. Okay? Because this only graphs functions. Circles are not functions. If you guys remember the vertical line test? Like the test if something's a function. Do you guys remember that? Yes, no? Okay. Well, functions are things that if you have a vertical line, it only crosses your graph at one point. Well, a circle at all points except for when they're tangent crosses at 2 points. These type of graphing calculators only graph things that are functions that only cross at one point. Right? So I could type an equation that's equivalent to this in, but it's only going to graph the top half of my circle. Right? Desmos does the whole thing. It recognizes that it's the equation of a circle. And it's also something we can type it in standard form. Whereas the yellow calculators, it always has to be y equals, right? Which makes it harder. In this case, we can put it in standard form. This is a circle that has a center at 2, 3 with a radius of 4, right? Now we could do ones that, like here's that one that had a, the radius that was 2 radical 21. Let's make one of these. +3, zoom out a little bit. There we go. So here's one that has a center at, if I click on it, it might actually give me the center too. No, it doesn't. This center's at 2, -3. Okay, center's at 2, -3. And it has that circumference of 2 radical 21, which you can tell it doesn't cross exactly at a coordinate, at a whole number coordinate. Okay. But this is just a good way to check. If you do have to sketch a graph of a circle, this is a really good way to check and see if you did it correctly, just by plugging your equation in, right? Just gives you a good visual